welcome to AskPrep. My name is Aisha and I will be teaching you exercise 1.2 of your first chapter. Okay, we have already covered exercise 1.1 from grade 11. Today we'll be starting exercise 1.2. But before we move ahead, let us see what are the concepts that we are going to learn is exercise 1.2. I hope you all remember that we have discussed sets and the representation of sets, two different types of representations of set in our last video. In this video, we will be seeing the different types of sets that we have. So the first set that we would be discussing is an empty set. Now, any idea what is an empty set? As the name suggests, the set that does not contain anything is called as an empty set. Now, this is how I represent my empty set. There is another way of representing my empty set, that is this. What is this? This is again a Greek symbol that is read as phi. This is both the representation of an empty set. This is also how I represent an empty set. I either read it as phi and I read this as empty set. They are one and the same. Now, there are two other names for empty set. One is called as null set, and the other name that we have got is a void set. So all these three mean one and the same. And this is how I represent a null set. Okay, now I have a question. I am writing a set in my roster form, right? And it contains 0. Now, what do you think this is? Is this an empty set? Yes or no? What did we say? What did we discuss just now? There should be no elements in my set. Then only it is called as an empty set. But here we see an element 0. So this cannot be an empty set. It has to be completely empty for it to be called an empty set, a null set, or a void set. Okay. Now, I hope that's clear. Now, let's look at, this is one way of representation. Roster form, representation of null set. Let us take few real life examples and represent it in set builder form. Let's see how do we represent it in set builder form. Let us just briefly recall as to how do we write in set builder form. Braces, then X. How do I read this? Followed by colon. What is this X? X is a symbol which represents all the elements containing in the set. How do I read it? The set of all X, such that now I will write about that special quality of my set, or why am I calling it as, what does that element contains? What are those elements? Let us define those elements here. X is a student in grade 11 and 12 simultaneously. Is this possible? Can X, or I can write it as X is a student of grade 11 and 12 in the year 2004. In the year 2004. Is that possible? Or let us take down our current year. What is the current year? Why go back to 2004? Let's take 2024. Is it possible for you are also a student of grade 11? Is it possible for you to be in grade 11 and 12 at once? No, this is not possible. So this is a null set or a void set or an empty set. Let us take another example. Now, the set of all X such that X belongs to natural numbers and X lies between 3 and 4. Now, what is that? What is the number that is greater than 3 and less than 4 and is a natural number? Does such a number exist? No. That means A is again my void set or null set. Okay. So I hope you have understood what exactly a null set is. Now let's move on to a next type of sets that we would be talking about. That is finite and infinite sets. Now, most of you must have got an idea when I wrote the name. Finite sets, as we all know, they should contain definite number of elements. Now, I can say A is a finite set as it contains first 5 even numbers. Do I have definite number of elements? Yes, I have 5 elements in my set. So, this is a finite set. Now, I will say A is a set of all my even natural numbers. All my even natural numbers. Can I write all my even natural numbers? Not possible. So that is the reason why I have represented it by 3 dots. That means there is no end to my even natural numbers. So do you think this is definite? No, it is infinite. So this is an example of my infinite set, whereas this is an example of my finite set wherein I have definite number of elements in my set. Now I have a question. I am writing another type of set here. Now just let me know which type of set does it belong to, a finite set or an infinite set. What is this? This is a null set. So what do you think? Does it contains infinite number of elements? No, it does not contain any element at all. And it will come under the category of finite set. So how do I define my finite set? A set which is empty or contains finite number of elements. Okay, what am I saying? A set which is empty or which contains finite or definite number of elements is called as a finite set. Whereas a set which contains infinite number of elements is an infinite set. Now, there is also another way of representation of number of elements in a set. Suppose my set A contains, as we have discussed earlier, first 5 natural numbers. Now, how many elements do I have? The number of elements in set A are finite, that is 5. This is how I represent it. Now, suppose I have another set B that contains 3 elements. Now, I can represent it as number of elements in set B are 3. This will give me an idea as to how many number of elements are there and if the set is finite or infinite set. Now, let us try representing my sets in set builder form. Okay. Now, A is equals to the set of all X such that X is a natural number. How many natural numbers do we have? I have infinite natural numbers. So again, this is a infinite set. Okay. And how do I represent it in set build my roster form? 1, 2, 3, 4 by 3 dots. Yes, this is my set builder form. This is my roster form. Now, let me represent another set builder form. Now, the set of all X such that X is a real number. Now, how do I represent this in roster form? My real numbers could be in A by B form. It could be my integers. It could be my, there are different elements in my real numbers. Yes or no? Rational numbers, irrational numbers, all my elements, all the numbers that we have discussed come into the category of real numbers. So there is no way of representation of certain sets that can be represented in roster form. So there are certain sets that are in infinite sets that cannot be represented in my roster form like this one. So what did we learn? Few sets cannot be represented in roster form. Which sets am I talking about? I am talking about infinite sets. Now, I hope that is clear as to what are infinite sets and what are finite sets and how do we represent them in roster form and set builder form. Now, the next type of set that I am going to talk about is equal sets. Now, what do you mean by equal? When do you say equal? When you're comparing, that means I am going to compare two sets here. Okay, so let me name it as set A and set B. Now let us see what are these equal sets. Now, if the elements of set A are present in set B, now let us see what are the elements that we have in set B. This. And the elements of set B are present in set A, then such sets are called as equal sets. What are my equal sets? If they have exactly the same elements, you see, we exactly have same elements in both the sets, so they are called as equal set. Now, sometimes what may happen is, let us see another example. The elements may repeat. We have discussed in our last class that elements do not repeat. Let us see what happens if elements repeat. Now, 2, 4, 6, 2. This is my set A in roster form. Let me write down set B. 2, 4, 6. Now, are they equal sets? Yeah, let us check. What did I say? The elements of set A should be present in set B. 2 is present, 4 is present, 6 is present, 2 is present. Again, 2, 4, 6. So whatever elements I have in set A are present in set B, though they are repeated, yes, they are still said to be my equal sets. Though the elements might be repeated, but I will still call them equal sets because whatever elements I have in set A, I have the same elements in set B. Okay. Now, let us start with our exercise 1.2 and do few of the problems there and understand and get clarity as to what we have discussed so far. Now, I hope you are able to see this. Now, let us get started with the exercise. Now, as you all see, I have taken the screenshot directly from the textbook. So those who have the textbooks with them, well and fine. Those who do not, you can see it on my screen here. Okay. Now, let us read the first question. Which of the following are examples of null set? Now we know what null set is. It should not contain any of the elements. No elements. There should be no elements in my null set. Set of odd natural numbers divisible by 2. Are there any odd numbers that are divisible by 2? No, they are not. Odd numbers are not divisible by 2. So this is my null set. Next, let us go for third question. Now, set of all x such that x is a natural number, x is less than 5, greater than 7. Less than 5, greater than 7, not possible. No such number exists which is greater than 5 and less than 7. Now, let us have a look at the second question as well. Set of even prime numbers. Is there an even prime number? Yes, there is only one even prime number and that is 2. So what do you think? Is this a null set? No, this is not a null set. So fourth one, you can do it as homework. Now moving on to the second bit. Let me read it for you. Which of the following sets are finite and infinite? Now we have seen what are finite sets and what are infinite sets. Let us do two problems. Now, the set of months of a year. Can you count the number of months in a year? Yes, there are 12 months in a year. So this is a finite set. Now moving on to second question. 1, 2, 3, and so on. I have three dots. That means, can I count the number of numbers I have in those set? No, I cannot. So it is an infinite set. Now, let us go for the fifth problem. The set of third and fourth, you can take it as homework and give it a try. In case you're not able to do it, just leave comments below. We can do it for you. Now, the set of prime numbers less than 99. Can we have a count, or can we count the numbers, prime numbers less than 99? Absolutely. So this is another example of finite sets. Now, moving on to the next question. State which of the following set is finite or infinite. I think we'll just do one or two problems. First, starting ones are usually the easier ones. So I think I can leave the first three for you, or maybe I'll leave the first two for you, and we'll discuss 3, 4, and 5. The set of numbers which are multiple of 5. Can you count what are the multiples of 5? Oh my God, no. It goes on 5, 10, 15, 20, 25, on and on and on. So this is an example of infinite set. Fourth one, set of animals living on earth. Can we count? Do you think you can count? I think. What do you think? I think we can count. We do have a count of tigers, a count of lions, and all the animals. Yes. So this is a finite set. Next, the set of circles passing through the origin 0, comma 0. How many circles can pass through this? Should we give it a try? Oh my God. Again, I can form another. Again, I can form another passing through the origin. I can form as many as I want. So do you think they are finite or infinite? I think they are infinite. They go on and you can go on increasing. There is no limit to it. So yes, they are infinite. Now let's move on to the fourth bit. Now what do we have here? In the following, state whether A is equals to B or not. What are equal sets? They're talking about equal sets here. That means elements of set A should be present in my set B and vice versa. A, A, B, B, C, C, D, D. So all the elements in both the sets are covered. So I think the sets are equal here. Now moving on to the second question. 4, 4, 8, 8, 12. There is no 12 in set B, but it is there in set A. So one element is missing in set B, so they can't be equal sets. Now, I think you can do the third and fourth, or maybe I'll give you third as homework and we can go for fourth one. A equals to set of all x such that x is a multiple of 10, and B, what do we have here? 10, multiple of, there, we are only talking about multiple of 10. So they are 10, 20, 30. But I do have some numbers in between here which are not multiples of 10. So what do you think? So it is not an equal set. Now moving on to the fifth question. Are the following pairs of sets equal? Now let us give it a try to this. A equals to 2, comma 3. The set A has elements 2, comma 3. But in set B, what did they give? They gave us an equation which we have to solve. B equals to set of all x. Please read it along with me whenever I am reading a set which is especially in set builder form. That way you will get used to reading it and it will become easier for you. Yeah. B equals to the set of all x such that x is solution of x square plus 5x plus 6 is equals to 0. X square plus 5x plus 6 is equals to 0. So I think we can use splitting the middle term method and factorize. So 6 and 1. So 6 times 1. I hope you all remember this. 6, you will multiply a and c and then you'll find the factors of this. One factor is 6 times 1 is 6. The other factor is 3 times 2 is 6. I think this fits here. I can split it up as x square. 5 can be split up as 3x plus 2x plus 6 equals to 0. Now I can remove x common here. I will have x plus 3 plus in my second two terms, last two terms, I can remove my 2 common. Again, I'll be left with x plus 3 equals to 0. If I take x plus 3 common, I am left with x plus 2, which is equals to 0. So what are the values of x we have? X is equals to minus 3. Equate this to 0. Equate this to 0. You will get minus 3 and minus 2. So what are the values that we have of b? What is the solution? The solution is minus 3 comma 2. Here I have 2 comma 3. So that means they are not equal sets. I hope that is clear. Now let me do this second one as well. And maybe I can give you sixth one as homework. Give it a try. Now let's go for the second one. A is equals to the set of all x such that x is a letter in the word follow. So now let us write this is my A. Okay. What are the letters in the word follow? Let us write it in roster form. Okay. F. And what do we have? We did not repeat the elements. F, O, L. Can I repeat this L? I can't. It's already there. What do I have next? O is also there. So can I repeat it? No. I cannot repeat these two. Next is W. Now, what do we have in B? Let us write it in roster form. It would become easier. You can compare it this way as well, but it becomes more easier if you write it in roster form. Now, W, O, L, F. Should we compare A and B? W, O, L, F. So all the elements are exactly match. Whatever elements are there in A, I have the same elements in B. So what do you think? These are my equal sets. So sixth one will be given as homework. Give it a try. We need some practice. Yes, you need to practice a lot, especially when it comes to math. You can only learn math through practice. So that's all, students. That's all for today. I hope you found the lecture understandable. If you have any doubts, any questions, feel free to comment or email us. Yeah, goodbye and ask us anything.